Hi. Good day. We will now be presenting the study of Freddie B. Priyan S. and Dr. Thelma D. Paul Awag entitled, Modeling Document Labels Using Latent Dirichlet Allocation for Archive Documents in Integrated Quality Assurance System. Accompanied with the tedious accreditation process, there is a lot of documents that needs to be accomplished. Most experiences in the current accreditation undertakings, the majority of the tasks were done manually. Though there are available tools for automation, however, problems such as repetition of work, invalid instruments, inefficient resource utilization, and inefficient monitoring before, during, and after the accreditation are still experienced. Therefore, to address the current situation in accreditation process of CSPC, the researchers came up with the study that supports the categorization and automated tagging of the archive documents used during accreditation. Through the system, document searching and matching will be easier, and duplicate documents may be eliminated. As a guide in modeling the research, the researchers uses the Agile methodology. It is a fast-phase technique, however the documentation and models are still valued and does not sacrificed for the sake of speed. Even if the development process is fast, the chance of the project failing is low because of the continuous integration. These are now the phases in Agile methodology. Plan phase. In this phase, the researcher conducted data gathering that will be used in the proposed study. The researcher also identified how HEIs understand the existing process. The scope of the study was also defined as well. Further, the specification document was prepared to identify the data needed in the study. Design phase. The researchers gathered all necessary documents in this phase that helped determine the needed requirements in the study and identifying the needs of HEIs involved in terms of accreditation and quality assurance. Develop phase. The requirements analysis is the output for this phase, the initial findings of the study is discussed, and the architecture design of the component is created. Identifying the dataset corpus and pre-cleansing of data is also part of this phase. Moreover, the model for text classification pattern has already been created. Deploy phase. For this phase, the researchers implement the model created and uses a machine learning tools to deploy the data for classification and clustering. Review phase. During this phase, analysis of results has been made. Another cycle of modeling was undertaken due to the discrepancy on the result. Utilizing another tool was already been considered. Launch phase. In this phase, the researchers package the component for release. The component is ready for embedding in the integrated quality assurance system. Next, may we present to you the intelligent model and design prototype of the proposed system. And also, we included the computational analysis of label extraction from the sample document to be used for automatic labeling or tagging. The researchers used a text classification pattern embedded with the latent dirichlet allocation or LDA. This model is utilized to identify the labels from the process document for possible keyword tagging. The accreditation documents will undergo different phases to extract and visualize the possible labels for auto tagging as shown in the figure. It will go through a pre-processing stage to clean and tokenize the document. This process will remove symbols, numbers, and duplicates from the accreditation document. Next is to set up the parameters that will be used in label extraction. This includes the desired number of topics, frequency of iteration, the number of labels to be generated, and optimization interval. All of these are necessary in identifying the vocabulary density, readability index, average words per sentence, and frequently used in the corpus. The result from these is used for visualization in Super Word Vector and histogram. The Super Word Vector is presented in a cloud map word to visualize the frequency of the words in the corpus. On the other hand, histogram is used to present the relationship of the words per sentence in the form of line graph. Then the extracted labels and generated word vector and histogram will be tagged and linked to the uploaded document. This model is implemented in the integrated quality assurance system to assist in categorization and searching in the file repository of accreditation documents. For design prototype, we focused on the label extraction feature for automatic tagging of the archive documents used in accreditation. Upload and clean. As shown in the figure, this phase allows the user to upload and clean the document through tokenization. Once uploaded, the user may set the configuration in cleaning the document. The options are removing numbers, symbols, and duplicates, adding and uploading additional stopwords, and showing and downloading the pre-processed data. There are other useful features, particularly in managing the stopwords, like showing the list of default stopwords and deleting the added and uploaded stopwords. Setting up parameters. Phase 2 is intended for setting up the parameters for topic modeling as presented in the figure. Right after uploading and cleaning the document, the user can set the topic modeling parameters that will be used in identifying and extracting the labels. The parameters included are the desired number of topics, frequency of iteration, the number of words per topic to be generated, optimization interval, and the model's name. These parameters are primarily the factors in modeling the topics and label identification for automatic tagging. Extract label. This phase as shown in the figure provides the result of the processed corpus from the processing of the pre-processed document and the parameters that have been set up from the previous phase. This shows the number of document uploaded, the total number of words in the document, the number of unique words, vocabulary density, readability index, average words per sentence, and most importantly the frequent words in the corpus. This frequently used words are extracted to be the label for automatic tagging later on. User can also set the items to be shown in the most frequent word. Along with the result of Phase 3, word cloud is also generated. Phase 4 as depicted on the snapshot is a super word vector view of the frequent words in the processed corpus. The most evident word in the word cloud are the frequently used words from the previous phase, which are faculty, activities, library, research, and materials. The font size of the word is based on how many times does this word were used in the corpus. With the result generated during third phase, this phase provides the histogram presentation of the sample processed corpus with the support of the LDA visualization as shown in the figure. The line graph provides the relative frequencies of each generated label per document segment. Auto tagging to uploaded document. After the 5 phases, automatic tagging of the generated labels will take place as shown in the figure. The document will be stored in the file repository of the IQAS. The uploaded document will have a corresponding metadata such as file name, file size, user, date created, tags, and the link of processed model. The file name can also be updated, and adding and removing tags can also be possible. For better understanding, we provide you the computational analysis of the actual result based on the processed document. In reference to the result on Phase 3, there are 4 significant results evident on the figure. Vocabulary density is the ratio between the total number of words present in the corpus and the unique words. To obtain the vocabulary density, the total number of unique words divided by the total number of word count for the sample computation, refer on the figure. The vocabulary density of the processed corpus is 0.254, which implies that the corpus contains complex text with lots of unique words. Moreover, the readability index, an average word per sentence, uses Java break iteration, which is a local sensitive class that has an imaginary cursor pointing to the current boundary in a string of natural language text. This contains different kinds of boundaries such as for text character, words, sentence instance, and potential line break. These boundaries are the basis for the readability index and average words per sentence, which are 16.106 and 21.5 respectively. Frequently used words are identified based on the number counts of the word used in the processed corpus. On the other hand, the LDA visualization is presented through the correlation of the relative frequency of the word per document segmentation as shown in Phase 4 figure. To identify the relative frequency, it's a must to decide for the number of document segmentation. For the purpose of this study, the researchers used 10 for segments of the document. The grouping of words per segment are based on the total number of word count. The prototype now will determine how many times does the particular word was used per segment. Upon determination, the identified number of counts will be divided into the total number of word count. For the sample computation, refer on the figures provide. For the overall result on the histogram, these 2 tables presents the tabular representation of the relative frequency per label and per segment. For the conclusion, CSPC is in exploratory phase when it comes to solving this particular problem involving accreditation. It is evident that there are problems encountered by the organization pertaining to the accreditation process. Therefore, the researchers devised a model supports the organizations of archive documents for accreditation. In addition, the researchers also design a prototype with the implementation of the model to help the organization through the process. As a result, it is easier to retrieve and classify the data, which is the main problem of the task group. Furthermore, other text classification patterns may also be integrated to the system and compare the result with a given parameters. These are the list of references used in the paper. That ends the presentation. Again, these are the authors of the paper. Freddie B. Priyan S. and Dr. Thelma D. Paul Awag. Thank you and stay safe always.